Welcome to North Campus Calculus Problem Solutions. This is Chapter 1, Section 1, Lecture 8, Power Functions. In this lecture, we are moving on to power functions, one of the most fundamental families of functions in calculus. Understanding how these functions behave will help you throughout limits, derivatives, and integrals. Do not forget to subscribe to the channel and leave a comment if you have any questions or suggestions. Let's start with a quick overview of power functions. A power function is a function of the form f of x equals x to the n, where n is a real number, positive, negative, or a fractional. Power functions describes how a variable changes when raised to a constant power, and their behavior varies significantly depending on whether n is positive, negative, or fractional. It is a simple and fundamental type of function. If n equals 1, then this power function is a linear function. If n equals 2, it's a quadratic function. Its n is negative or fractional and gives different behaviors, which we will see in later sections. In calculus problem solutions, power functions often appear as the first step in many problems. For these sections, it's enough to know what a power function is. We will see problem applications in upcoming videos. First example, find the domain and range of the function f of x equals x. F of x equals x has a line graph as this, and this has here 45 degrees, and the domain of the function y equals x is all real numbers. In other words, you can plug any real number into this function, and the function will always produce a valid output. So the domain will be real numbers. The range of y equals x is again all real numbers, since the function continues indefinitely here in both positive and negative direction, and it can produce every real values as an output. So the range will be real numbers. The second example, find the domain and range of the function f of x equals x square. The domain of the function y equals x square is all real numbers again. In other words, you can plug any real number into this function, and the function will always produce a valid output. The range of y equals x squared is all real numbers greater than or equal to 0, since squaring a real number cannot produce a negative value. So the output starts at 0 and increase without the bounds. So the domain will be real numbers and range will be from 0 to infinity. And the third question, find the domain and range of the function f of x equals x cubed. Again, the domain of this function y equals x cubed is all real numbers. In other words, you can plug any real number into this function, and the function will always produce a valid output. And the range of y, so the domain will be all real numbers, and the range of y equals x cubed is all real numbers again, since the cubic function continues indefinitely in both positive and negative direction, and it can produce every real values as an output. So the range will be all real numbers. The next example, find the domain and range of the function f of x equals 1 over x. The domain here, the domain is all values of x for which the function is defined. For f of x equals 1 over x, the function is undefined when the denominator is 0 because the division by 0 is not allowed. Therefore, x equals 0 is not allowed in the domain. So the domain will be all real numbers except 0. Or we can write it here as minus infinity 0 and 0 to plus infinity. The range here is all positive values of f of x that can take. Since f of x equals 1 over x never equals 0 because any number divided by 0 is never 0. Y equals 0 is not included in the range. And as x approaches 0 from positive direction, f of x goes to plus infinity. And as x approaches 0 from negative side, f of x goes to minus infinity. As x goes to plus infinity or minus infinity, f of x goes to 0. As x goes to plus or minus infinity, f of x goes to 0. But never actually reaches 0. Therefore, the range will be minus infinity 0 and 0 plus infinity. And the next question, find the domain and range of the function f of x equals 1 over x squared. Again, the domain is always all values of x for which the function is defined. For f of x equals 1 over x squared, the function is undefined when the denominator is 0 because the division with 0 is not allowed. Therefore, x equals 0 is not included in the domain. So the domain will be minus infinity 0 and 0 to plus infinity. Range. Again, the range is all possible values of f of x can take. Since f of x equals 1 over x squared here is always positive for any non-zero x, so 1 over x squared is always positive. And as x goes to plus infinity or as x goes to minus infinity, f of x approaches to 0 but never actually reaches to 0. And as x goes to approaches 0 from the positive side or as x approaches to 0 from negative side, f of x goes to plus infinity. Therefore, the range will be from 0 to infinity. And this was the last example. We will see in the next video. See you.